We are joined today by Dr. Sophia Frangou, who is a professor here in the Psychiatry Department and the UBC President's Excellence Chair in Brain Health. She is an internationally recognized expert in neuroimaging and psychiatry research, serves on the editorial boards of several leading scientific journals, and is editor-in-chief for both Human Brain Mapping and European Psychiatry. So thank you, Dr. Frangou, for sharing your insights on publishing in AI today, and I will let you take it from here.
Thank you very much, Nicole, for organizing this, and thank you to everybody who is joining. I'm quite happy to take questions as we go along. I'm not able to see everyone, so I'm quite happy with people to just ask questions directly without necessarily raising their electronic hand or anything. So starting with some sort of basics, a lot of the tools that I'm going to discuss today are developed by different companies. So I just want to make it clear that I have no financial or any other affiliation with any of these companies that are involved. The second thing I would like to highlight is that the purpose of this presentation is to provide information about the different tools, AI tools that are currently available for scientific writers, not scientific publishers, but for writers. And when you are personally considering to use, or if you're planning to use AI tools, it's very important that you adhere to institutional policies. So the UBC has institutional policies about the use of AIs, particularly generative AIs, and we will cover that in a minute. And the link is there for you to visit the guidance and be aware of it. And of course, it's important for those of you that work within labs or research groups to discuss what is the general policy, what is the general approach that your lab has to using these tools. So this is the framework within which we are discussing these AI tools. So I will be talking about three types of tools: the generative AI tools, tools for AI-driven scientific analysis, and tools for journal recommendations, which perhaps are the ones that you're least familiar with, but they are there and they can be used to inform your choice of journals. So the generative AI tools and the AI-driven scientific analysis tools are actually quite important for manuscript preparation. So this is where most commonly you will find a use for these types of tools. So we start with the generative AI tools. So they're called generative quite unimaginatively because of their ability to produce or generate new data or content. That's the basic characteristic of these tools. They're usually based on a combination of large natural language models that can actually represent language in different ways that can be captured, essentially computationally and mathematically. And they're based on an architecture that is called a transformer architecture. So this architecture consists of two components: the encoder that takes the language representation and turns them into conceptual representations, and the decoder that actually generates the new content. It's not required that you know the details of these particular things, but if you're interested as to what is the magic that happens behind the generative AI tools, it's based on this particular architecture that changes language into essentially representations, both conceptual, creating conceptual representations, and then generating new content based on these representations. There are several generative AI tools, ChatGPT. But whenever you see something in brackets, is the company that has actually developed this particular tool, in case you're interested. Sometimes it's important to know who has developed what. So ChatGPT is definitely at the forefront of this generative AI tools in terms of how much it has captured usage and also public imagination. But there are other tools. I'm not listing every single one of them, but Gemini and Grok. Gemini from Google and Grok from xAI are two other tools that are very commonly used. So Gemini and Grok have trained their concept, have learned their language representation by using specifically content from Google and X. ChatGPT is a little bit wider in terms of where it has actually learned and trained in terms of the basic algorithms behind the content generation. So just because ChatGPT is perhaps a little bit more likely to be useful in the scientific content, I will just focus on ChatGPT for now. But very, very similar functions are available in any other generative AI that you might come across. The basic sort of user interface is very similar. It has a prompt where the user writes whatever it is, a question, a request, some other command, and it has an interface where the content is being generated. When we talked about policies with regards to generative AIs within institutions and within teams, it's also important to be aware that there are editorial policies from the different scientific publishers. So the scientific publishers are companies for profit or non-profit that publish the journals that we submit our papers to. And each of these publishers has its own editorial policy. They're usually very clearly articulated at the website of its journal. And again, before you decide what approach to take, it's important that you are aware of the editorial policies of a particular publisher. These policies focus mostly or practically exclusively on the generative AI tools. And although there is some variation between different publishers, generally, things like ChatGPT do not meet the criteria for authorship. So if you use ChatGPT, you don't need to list them, or another generative AI, you don't need to list them as an author. And the reason for that is that authorship implies accountability for content. Implies agency, that there is an intention behind what you're doing, which cannot be attributed to just simple algorithms that like ChatGPT. However, again, most, if not all, the journals require that you state in the methods if and how you have used any of the AI tools. And again, there's variation across journals, but those are the basic principles. You don't need to mention generative AI as an author, but you do need to mention how you have used such tools in the methods. So what tools can we have what use can we have for these generative AIs? So what should not be done is to use the generative AI to generate the text for your paper. So that is universally considered extremely bad practice. And in addition to being bad practice, it doesn't, the models that are available at the moment are not sophisticated enough to be able to write a scientific paper in a way that would be of a very high quality. So I think you should never do that. ChatGPT and other has the potential to actually search the web for content that might be relevant to your paper. So it can function a little bit as a search engine for academic literature, but again, it is extremely limited in the way it does this. I wouldn't recommend its use in that particular way, but it is building that capability, I think, at the moment. What would be appropriate uses for this sort of models is to edit a text to improve language. So you have written something, maybe English is not your first language, and you think perhaps this can be improved a little bit in terms of editing, and ChatGPT can definitely help with that. Another thing that it might be helpful for, especially for researchers that are at the beginning of their career and they're kind of coming to grips with how to structure a particular manuscript, it can suggest an outline to assist with the storyline development. So you can actually suggest a way to structure your papers and things that you might want to consider when you're developing your content. It can provide statistical suggestions, and also it can provide code, either to actually produce the code lines within its response or direct you to appropriate functions within R or Python where you can actually implement your analysis. It can answer questions relating to academic issues. So you can ask, for example, does UBC have guidelines about the use of generative AI? And that sort of thing it would be able to respond to, or so similar kind of questions of that nature can definitely address, and it can generate images. So for those of you that joined at the very beginning, the first slide had an AI generated image. Most of the images that are generated have a particular artificial intelligence feel to them. I think you can definitely identify when an image has been AI generated. And very recently, ChatGPT has actually started kind of moving into scientific diagrams and scientific picture development. And sometimes it will actually offer the service to you as a prompt, says, would you like me to create a diagram to illustrate the point of what you have done? The scientific diagrams at this stage for ChatGPT are extremely basic, and I wouldn't actually recommend them, apart from kind of if you want to play around with the tool, but they are not really of a quality that can be used in any scientific publishing. But it can definitely generate conceptual images if you want to enrich a PowerPoint presentation, as I have done. So those are essentially the 5 most likely helpful uses of ChatGPT. And I will just want to show you a couple of examples of what the prompt and the output can be in this particular context. So as I said, it can provide a storyline. It can help you structure your paper. So the prompt here is provide an outline of the introduction to a paper on subtyping major depressive disorder based on cognition. And so it has actually provides bullet points, says, and the structure of the introduction. You don't have to follow it exactly, but sometimes when you're thinking about how to go along putting everything together, it might give you some useful ideas. So the highlights are mine. The text that is generated from ChatGPT it doesn't have different colors or anything. But I just sort of put it here to show you how it provides, in this particular instance, 5 different paragraphs, and how within each paragraph it actually suggests particular topics that you might want to develop. Again, this is not meant to be followed blindly, but it's not necessarily it is a function, however, that could be useful, and again, mostly for people at the beginning of their scientific writing careers, where they sometimes need a little bit of help to kind of structure their thinking around a particular topic. So that's one type of, as I said to you, it can actually provide some advice about statistical analysis and planning. So here, the prompt is provide statistical analysis plan and associated R functions to test whether cluster membership predicts of some hypothetical clusters, predicts psychopathology levels at 3-year follow-up. And again, it offers you some assumptions that cluster membership has already been obtained somehow, that when you say psychopathology, you mean a continuous variable like symptom severity score, and it gives you some ideas about what you might want to control for, like, so just to remind you that that there might be other variables that you might want to consider as covariate. And then it actually provides a plan. Again, you don't have to follow it exactly, but sometimes it gives you an idea of how to approach a particular problem, and it will also sort of suggest to you a particular way to approach to develop a first level analysis plan that might be helpful. Again, for people that are beginning their scientific careers and they might want a little bit of assistance or prompt just to think about different ways that they can approach their analysis. ChatGPT can definitely be helpful with that. Again, I cannot emphasize it enough. These things are not to be followed blindly. They are just aids and suggestions that can help you develop your thoughts around a particular topic, being the introduction to a paper or being an analytical plan that you might not have a very clear idea or as to how to approach it to begin with. And of course, we all work within larger teams with supervisors and colleagues that are there for us to discuss and develop more fully our research ideas, be it in terms of the introduction of a paper or a particular analytical plan. And here is what I meant in that it actually can provide the associated R functions and example code to help you further implement a particular analysis plan, which sometimes is quite helpful. At the very least, to direct you to the library within R or any other. It doesn't just do R. This particular prompt has R as because a lot of people are using it, but can direct you to the particular functions that could be helpful for your analysis. And that's just one example where ChatGPT can be of help. I also mentioned that it can, ChatGPT and similar engines can give you basic answers, not complete answers, to scientific questions, academic questions. So this is an example of that. So the prompt here is, what is a support vector machine? For example, you went to a lecture, you heard a lot of terms that you're not particularly familiar with. So you can Google them, or you can go to ChatGPT and ask this question. And usually, although Google now has a little bit of an AI tool in it that can actually do a little bit of this types of analysis, but ChatGPT is usually a little bit better in providing quite sophisticated answers to basic academic questions like this, especially definitions of different things. And it can be it can be very basic, but you can actually improve the prompt and ask for more specific information, like what are the key features of an SVM, what are the common uses, and it gives you a little bit of a summary at the bottom. So it actually helps you shape your understanding, the basic understanding around a particular theme. Here we use support vector machine. It could have been anything. We know what do we mean by GWAS analysis, for example. It will again give you some information about basic topics. And in that sense, in helping you come to grips very quickly with the very, very basic definitions of some scientific terms, I think that is definitely one of the useful applications of the generative models. So we just finished anything that had to do with the generative AIs. I will pause here to see if anybody has any specific questions so far. Hearing none, we move to a different class of analytical tools, and those are AI-driven scientific analysis tools. Again, there are several around. I'll just sort of highlight three. We have Cite AI, Semantic Scholar, and Consensus AI. So these tools do not generate content in the same way that ChatGPT does, but essentially they are advanced search engine. They help researchers identify scientific articles, and some of them have an inbuilt sort of feature that can provide a summary of the literature that has been identified by the particular tool. As for the generative AIs, it's important to note that these are not the only tools that you should rely on when you're doing a literature search or when you want to evaluate aspects of scientific literature, but they are a very good starting point. So the CITED, all of this, again, in the brackets are the companies that have developed these different sort of models. So CITED uses citation context classification to give users an understanding of the paper's influence in the field. So it doesn't just find the literature when you have a prompt, but it helps you understand how important a particular paper has been in the literature. Semantic Scholar uses machine learning to extract key phrases, influence scores, and provide paper summaries. And Consensus AI uses natural language processing to analyze scientific papers and generate a summary. And each of the claims that the output makes is linked to a specific source, so the DOI of the paper, for greater transparency, because one of the issues that people had when ChatGPT was used to in the very early sort of stages of ChatGPT, when you ask different questions, for example, about tell me what you know about hallucinations, schizophrenia, it could generate what people call hallucinations, but essentially there's not hallucinations. The machines do not hallucinate and the algorithms do not hallucinate, but it would generate fabricated content, essentially, that was not specifically linked to any source documents. So these AI-driven scientific tools have been developed specifically to avoid any of this, and they are actually based on extracting the literature and summarizing the literature. They have different sort of, I think they are very useful, as I said, in helping people identify the basics or do a very quick and basic search literature search and create some very basic summaries, but they are just aids that can help you develop your overall strategy when approaching and evaluating the literature, not that they should be relied on exclusively. There are two other types of AI-driven tools that are separate from the above. So one is called LitMaps and the other one is called Research Rabbit. And they are less sophisticated than the ones before. And essentially the key figures is to actually provide interactive maps and identify through visualization how papers and authors are related to each other. So if you want to see, for example, the impact of a paper in terms of who is citing my paper, for example, lit maps are a very good way of doing that. So they won't necessarily provide you with in-depth summaries or information about different aspects of the literature, but they can identify how papers relate and authors relate to each other. And it can be, again, nice when you want to present something about your own papers to show how they have been cited in the literature. So we're going to see some specific examples of that. So this is Consensus, and this is the login page for Consensus. It can be used for free. All these AI tools that I've discussed so far and the ones that I will discuss in going forward, they have a free version that has the very basic features and a version of where you have to actually pay for their more advanced features. But even the basic features that are available for free are, I think, actually quite useful. So here is the page for Consensus, one of the AIs that we discussed that can actually summarize the literature. And you have to put a prompt, you have to ask a research question. So here the research task that I put in the prompt is review the literature on normative modeling in psychiatric neuroimaging. So this so Consensus will do two things. It will provide a summary, and it's very lengthy, so I couldn't capture the entire screen, but it will provide a summary with the key findings and have the specific references, and they're here shown in numbers. But you can actually go to the specific references that is being used and it gives you a sense of how highly cited a particular publication was, where it was come from, and you can actually click and read the specific paper if you're interested in. So it's difficult to see the chat when I'm presenting, but I think there was something in the chat. So whoever put everything in the chat, can you just ask the question using your own voice? No?
Yuetong says that the pro version is free 3 months for university students.
Yeah, I tried it out and I really like it, and I just want to bring the message that the Constance is free for 3 months for university students if you have the educational email. So yeah, I think everybody should try it.
Okay. So again, for everyone, please just unmute yourselves and ask the questions. But again, this is consensus side. AI is not that different from this, but and it has some other functionalities if you sort of spend some time looking into it, that can help you further understand the literature. And we discussed lit maps, and we said that they are different from what consensus AI can do, but they're very good in visualization. And here is a visualization of a paper by somebody in our team, so that you can see the title of the paper on the side. It actually gives you the number of references that it has, the number of citations, who is the author, the DOI, so that you know it's a real thing, and then it actually gives you the direct links to the papers that have cited that particular paper. So it's a nice way of showing the impact or examining more closely the impact of a particular paper. It doesn't do that just for papers. You can do it for some sort of concept, but I think it works definitely much, much better if you just if you're looking at a specific paper as opposed to something much more complicated. It's very good at steps like that. So, so in this section, we essentially covered the generative AIs, the AIs used for scientific analysis, and we're going to go now into the final sort of section of the presentation, which focuses on the tools that can be used for journal selection, which I think perhaps you're at least familiar with. But before we do that, I will just pause for some discussion or comments or questions. I don't know if people, what I'm saying is something that people are extremely familiar with, or this is relatively new information. But you let me know afterwards. Okay, so we are moving to journal selection. So, of course, everybody knows how important it is to choose the right journal after you have your study completed, because it increases the likelihood of acceptance, it promotes visibility and impact, and it ensures that it reaches better the target readership. So usually when people are thinking, where shall I send my scientific paper to, what they consider is whether the scope and focus of the journal align with the paper. People actually evaluate whether the journal can effectively reach the intended readership, the credibility and the standing of the journal in the field, especially as it's reflected in metrics like the impact factor or the journal's publisher, and kind of whether the publisher is a commercial or a non-profit publisher, or whether it belongs to some sort of a predatory publishers. And I think Nicole has arranged for a presentation specifically on this type of topic as part of this series. Of course, now open access is recommended generally for the papers, and open access comes with costs that are shifted. Before the model that we had, all the publication costs were being paid by institutions through subscription. So UBC would subscribe to a publisher like Elsevier, and therefore everybody who had a UBC affiliation could access or submit papers to Elsevier without having to pay a publication fee. But now the publication costs are being shifted to the authors. This is the new model of open access. And they come with an article publication costs, which is important to be aware of, although some of the publishers, but not all, and definitely not the majority, they still have specific agreements with different institutions, so that the institution still covers the cost of open access, and it's not paid by the investigator themselves. So UBC has such waiver agreements with Elsevier and with Cambridge University Press and a couple of other publishers. And you can actually Google it and find the website and be aware of the types of journals where you can submit papers as open access without having to pay the article publication costs. Another consideration, of course, is the timeline. Different journals vary in how fast they process papers, and that's a very important consideration. And finally, as we said, the choice of open access or subscription based, which depends on how likely it is that you will be able to cover the open access cost if you decide to go down that route. So those are the general criteria, the general considerations that people have when they are thinking about which journal. And then when those are the criteria, that sort of the decision-making process depends on experience. Some people develop some sort of personal publication history with different journals or different publishers. Sometimes particularly senior authors have some familiarity with the editors that might sway their decision-making. People ask traditionally for recommendations from mentors or other peers when they're considering different journals. The reading preferences of the authors are also a consideration. If there's a journal that you know that people in your lab or people in your field read quite regularly, that would be an important consideration. The scope, as we said before, and the metrics, like the impact factor of the journal and so on. So when we do it like this, using kind of natural networks and natural decision makers, we do limit our options in terms of, because we're not always aware of all the possible options that we have in terms of publications. And if we are to start searching each individual journal and start a comparison, it can be time consuming and quite inefficient. And this is exactly where this generation of AI tools comes in. They are there to facilitate journal selection. There are different models that have been developed. So one type is what's called the manuscript-based analytics. So the AI analyzes manuscript content, the manuscript you want to submit, and suggests journals that are aligned to the scope and have published similar articles recently. And often, but not always, it gives you an estimate of your acceptance probability, which is, again, something not to be taken as given. It's just a probability and just an output of this particular algorithm. Another type of algorithms is the metrics-based filtering, where the AI selects journals based on impact factor or age index or whatever metric you put in. So you might say, I want papers in neuroscience with an impact factor, journals in neuroscience with an impact factor of X, and they will generate some options for you. And of course, some more advanced models allows you to actually build a researcher profile, and therefore they tailor the suggestions based on your history and your previous kind of, and the knowledge that the AI built of your overall preferences and the topics that your research is based on. So it's becoming quite sophisticated in that respect. So what AI tools are available to us? So most of the large publishing houses have developed their in-house journal recommendation tools. And you can see Sage, Wiley, Elsevier, Springer Nature, which are the major publishers. They have their own sort of link. It's AI enabled, but it only recommends journals that are published by that particular publisher. So if you go to the AI tool for Sage, for example, it will return options that are journals published by Sage, nothing else. It won't look at the entire field. It will just give you recommendations based on the journals of that particular publisher. Nevertheless, you can use multiple, of course. You can use more than one tool, but at the same time, these publishers are involved in a huge number of publications, so their tools are actually quite helpful in that respect to identify potentially helpful suggestions for journal submission. However, there are other tools that are not linked to any particular publisher. And I will mention a number of those. So Trinka is one type of journal finder, and as is Enango. Enango is specifically helpful or exclusively helpful in finding open access journals. Most of them, again, like a lot of the AI tools that we discussed so far, are have a level that is free and another level that is actually subscription based, but even their basic sort of features are actually quite helpful. Other researcher tools are the Researcher Life and the Jane, and here as you can see, how they function is by you entering the abstract or the sort of basic outline of the paper that you have, or if you have the entire manuscript, you can upload the entire manuscript, and they will try and find the journal that matches the context of the paper or the abstract that you have actually uploaded. So they are context-based research engines. And this one, the ENDAS, is also one of these journals that can actually give you a lot of versatility in terms of what how you want to search for things. It can help you search by abstract or keyword. You can, if you want to know specifically about a particular journal that somebody mentioned, you can search by journal name. Or again, if you're interested in a particular publisher, it will allow you to do that, or in a particular field of research. So it has a lot of flexibility in terms of generating a recommendation that is tailored very much to your custom recommendations. And it does cover the vast majority of publications and publishers available. So I mentioned to you earlier on that UBC has open access publisher discounts. This is actually the website where you can go to find specifics. Again, whoever has put up their hand, could you just please unmute yourself and say whatever it is you want to say?
Absolutely. Do you have any words of caution, or if we're uploading information that's not being published to these AI websites or ChatGPT, what happens to that information? Do you have any words of caution or things that we shouldn't upload? Because I'm assuming once I've uploaded it, others can learn from it. And I suppose, for example, if you're accessing population data BC information, which has to all be pre-approved before you can submit for publication, words of caution, anything we should not be uploading?
So I'm not entirely sure. You're referring to the journal finders.
Yeah, I guess so, yes. I suppose anything, refining language.
The journal finders are not trained on your content. They're trained on the content of the journals.
Okay, so then what happens if
The
I'm
journal finders, yes, they do not care about your content. There's nothing they can learn from you.
okay?
The only thing that they use, and again, you uploaded an abstract that you intend to publish, so it's not supposed to be. It's something that you want to make published. So the journal finders are trained on the journal content, and they use that training. They apply that training to what you're uploading. There's nothing that they need to learn from your data. Their only job is to make a recommendation with regards to the alignment between whatever it is that you submitted and what is described, the criteria that you specified, and what is described in the journal scope. And depending on the sophistication of the engine, depending on the sort of on other features, like the most recently published papers in that journal or by that publisher on that topic.
So
But they're not training on your data. There's nothing for them
understood.
to learn.
That's good to know. So then what happens if I'm uploading, say, text from my manuscript or abstract that I'd like a bit of hand with revising, to ChatGPT? What happens to that information?
So that information, it depends on your level of subscription. So if you are a subscriber to ChatGPT, it would not use your data for learning. But again, what these engines learn are conceptual representations. They're not going to use the text you uploaded to give it to someone else, if you see what I mean.
Okay, no, that's useful to get that in.
And of course, you'd never upload data as such. So if you have an Excel spreadsheet, you're not going to upload this and say to ChatGPT, analyze this thing. It won't do that.
Mhm.
But if you write something and it says, that looks a little bit crappy, and you put it in ChatGPT with a prompt, improve language clarity, for example, or edit for clarity, it would just edit what you have given it.
Okay.
They're not that clever, and sort of the concern that something may be taken and given to someone else, it's actually probably quite exaggerated.
Okay.
The biggest concern is that people, especially for the generative AIs, that people will use them. And again, this was my last slide, so good luck to everyone. Another AI generated image here. Just to show you what you can do. So I'll stop sharing and we can have a discussion about, what you think. That is it. Enjoy the rest of the day.